is the size of the hole, you can just allocate the first one, lowest address, the chunk. So it depends.
Why it depends? The worst fit, I think, is wasting the result.
So worst, let's see the example of this. The first fit will be this one. That is the best fit, and worst fit is either this one or this one. But you still have the bigger size of the chunk. Okay. So for example, this one may not be used forever because it's a small fragmentation. Okay. Because you try to make small chunk available space, right? So you may not utilize the remainder of this. So if you use worst fit means so you make the larger the available chunk, available space, so it can be reused for small process. But even this one may not. So that in that case, if you don't want the fragmentation in the memory, you can use the worst fit. Right? So it depends. So if you don't want to calculate, you want to make the simple algorithm for the allocation, the first fit is better. So there are two types of the fragmentation. As we have seen before, internal fragmentation means inside the segmentation you may have something, because there might be the smallest. So let's say this is a freedom block, snap block, it will be page later. Okay? Page later. So you may not utilize the small chunk of the available space, that is the internal fragmentation. In external fragmentation is partition by partition. When you have the 100 megabyte, 100 bytes, the available whole chunk. If your process, all your process are bigger than the 100 byte, you cannot use this one. This is the external fragmentation. So we'd better remove such an external fragmentation as well as the internal fragmentation. To do that, we can use the pacing. Pacing is the fixed size of the memory space. Okay, like instead of such a chunk, we can consider like the 256 byte memory unit. Okay, this one, no matter what size of data processor you have, it will allocate page by page. It's the same idea as block-based I/O in file system. Okay, that is a pacing. Before that, sometimes when you allocate the process to the memory, so this is the, for example, the foo.exe file. Then this foo.exe use a lot shared library, that is the io.s. They are working together. At that time, why don't we make the group of such a partition processes in the memory? That such a logical group is called segmentation. Instead of allocate the process by process, you can allocate the memory for segmentation by. This segmentation is a group of such a partition that those are working together. It will be the same idea in the later pacing. Pacing, you can make the group of the page that are working together each other. You can save a lot of actually the page in and out, okay, by grouping the semantically similar the data. So for example, we can make the group or logical unit of the program, like sometimes the main program, like the foo.exe, sometimes we have the function to read or print the data. So they are, if working together, why don't we make the group of the process partition? Then we allocate such a segment by segment. Then we can get the benefit of read the data. Okay? I can make them group. So 1, 4, they are working together. So why don't we put together? And 2, 3 is work. To do that, CPU should know where such a segment exists, right? So we can manage just like the process, the relocation, the base and the limit, the registration. So we can have the segmentation table. That is the same idea as the memory mapping table. So we have the address of each segment and the size of the segment. Do we have any class after this?
Usually not.
It's usually lunchtime. Okay, so that is it's the same thing. It's a base register base address of the such a segment, and this is the length size of the. How can we find? By adding the SDVR and STLR. What are they, by the way? It's a register. So when you learn the microprocessor, you probably learned the register, different types of register, the base register and the limit register and the relocation register. This is another one. Some of the CPU architecture use this one, sometimes not. Okay, it's depending on, I don't know, I cannot remember which processor CPU are using this one, but this is the idea. Okay, but it's not actually. We are not using such an idea in the current computer system. Instead, it will be based on the paging, page by page, but we can group the semantically same the group of the page. So we will see such an example later. Okay. So that is the segmentation architecture. Okay, so from the CPU, so we need to manage such a segmentation table as we have seen before. So that is the segmentation base register, okay, and this is the length of that. So by combining this one, so this one has the mapping table. Then we can add. If that is out of range, definitely it's the trap. It's add exception. Handling, otherwise we can eventually find the specific segment and leave the instruction. Then CPU will process it. So that is a segmentation based the process memory management. So this is the example schematic view of the example of the segmentation. So there are 1, 2, 3, 4, 5 different segmentation, and also we have the segmentation table. This address is managed by the register. Okay, by pointing this one. Also, you should know the segment you are accessing. Then this is the limit 400 and the base is 6,300. So you can go to the 6,300 and up to the plus 400 the limit. Then this will be segment 1 and read the instruction by instruction to the register, then process it. Process means execute your instruction. Then, I think the next class, so we will continue the paging. Okay, so this is the most important part of the memory management. Okay. By the way, when is the due date for the second project?
December 2nd.
It's after Thanksgiving, right?
Yeah.
Okay. There is no the extension, no chance, no way. Okay. So even don't think about any extension of the project. Okay?
Was there